Okay, now we're going to do question 6. So question 6 is an angles, circle properties sector kind of question. So we're going to start with 6a. Okay, so for 6a, they want us to find the angle ABD, which is this angle here. So how are we going to do that? So first we know that angle ABC, which is this entire thing here, is 90 degrees. Let me write it down. Why? Because it's an angle in a semicircle. Okay, so once we know that this is 90 degrees, we know that angle DBC, which is over here, this angle here is equals to angle DAC because they are angles in the same segment. Okay, so angle DBC equals to angle DAC equals to 23 degrees. Why? Angles in the same segment. Okay, so once we find out our two angles, we can now find angle ABD. Simply just take 90 degrees minus 23 degrees and you'll get 67 degrees. Okay, so this is 67 degrees. This is 23 degrees. Okay, okay, now we want to find angle EAD. So EAD is over here. So how are we going to do that? So angle EAD is actually quite simple. So we first find angle AED, which is over here. So angle AED is just 180 minus ABD. Why? Because they are angles in opposite segments. Okay, so angle AED equals to 180 degrees minus angle ABD. Equals to 113 degrees. So we write here angles in opposite segments. Now we can find angle EAD. So very simply, just take 180 degrees minus 113 degrees minus 42 degrees. So this angle sum in a triangle. Okay, so our answer is 25 degrees. Okay, now moving on to part B. So part B is the sector area question. So I've already labeled all the information in the diagram given. So this part here is 4 cm, OS 6 cm, and then the minor sector's parameter is 15.2 cm. Okay, so how we're gonna solve this is a 2-mark question. So we're gonna let POQ, which is this unknown angle here, we're gonna let it be theta. Let's set down the ground rules first. The angle POQ be theta. So now the arc length, we can now find the arc length. The arc length of PQ is 4 theta. Why? Because the radius is 4 cm. Okay, so now we can find the perimeter of the minor sector OPQ. So this would be 4 theta plus 4 plus 4. Okay, so this is 4 theta plus 8 cm. Okay. Yeah, so now we know with 4 theta plus 8 cm is 15.2 cm. So 4 theta plus 8 equals to 15.2. Hence, theta equals to 1.8 radians. Okay, so that is our answer. Okay, now to B part 2, we want to find the total shaded area. So the total shaded area is quite simple. So I'm going to do it step by step for you guys to see how this entire thing plays out. So our formula for area of sector, right, if you guys forget, is half r squared theta. Okay, so now we're going to first find the area of the minor sector OPQ. So let's do that first. So that is half times 4 squared times 1.8. So this would give us 14.4 cm squared. Okay, so now the reflex of POQ here, this entire angle is 2 pi minus 1.8. So this would give us 4.4832 radians. Okay, so I'm going to write it down here as well. Property is angles at a point. Okay, so now we can find the area of the major sector ORS. Now we have the reflex of angle POQ. So area of major sector ORS equals to half times 6 squared times 4.4832. So this would give us 80.6976 cm squared. Now we can find the area of major sector OPQ. So this is half times 4 squared times 4.4832, and this would give us 35.8656 cm squared. Okay, now that we have found all the areas of our major and minor sector, we can now finally find the total shaded area, which is simply 14.4 plus, we must minus away 80.6976 minus 35.8656. This would give us roughly around 59.2 cm squared. 236. Okay.